Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Question 3. We have a glass converging lens is used as a magnifying glass to observe a red ant. Showing the lens, the principal axis, and the two principal focuses, F1 and F2. On the figure, mark a point on the principal axis labeled A to indicate the suitable position for the ant. As we said earlier many times, the object should be located between the focus and between the lens and closer to the lens. It's preferred to be closer to the lens. So the expected position here, this could be A. Okay. On the figure, also mark the point on the principal axis labeled E to indicate a suitable position for the observer eye. The observer eye, it could be on the other side. Okay, so the observer could be on the other side here, like this. Let's now check where to indicate the image. The image will be to the left of F1, between F1 and the lens, where you are, if you have the object at A, so the image will be here, somewhere here. Okay, so it will be to the left of F1, so it will be to the left of F1. If you check your mark scheme, you can find that it could be we have different answers, because some students, they locate the object at the right hand side of the lens. Oh, you got my point. So but usually I locate the object at the left side. Okay, so to the left of F1. Underline the words to describe the image produced by the magnifying glass here. It will be for sure it's virtual and it's upright. You can underline, don't circle, to follow the instructions. So it's upright and virtual, and by the way it's enlarged. Okay. So no need here to draw, we are just trying to discuss more important points about magnifying glass. Okay, the red light from the ant passes into the lens. As the light enters the lens, state what happens to the wavelength and frequency. Refraction takes place, and as we said in refraction, according to wave equation, the frequency is constant, unchanged. But if the light enters the glass lens, what happens to the speed? Speed decreased and the wavelength accordingly decreased. They are directly proportional if the frequency is constant. So what happens to the wavelength? The wavelength decreased according to the wave equation, and the frequency stays the same. Is it clear? So the speed of light in air is the maximum value of speed of light, and when it enters any other medium, the speed decreased. Is it clear? State how the wavelength of violet light in air differs from the wavelength of red light in air. Okay, this part is related to dispersion, and you know that the one which refracts more is violet or deviated more. The one which is deviated least is red. And back, since here we are talking about violet light in air differs from red light in air, so it's part or segment of electromagnetic waves is visible light. And you know that it starts here by red, and here we have violet. Okay, here we have ultraviolet, here we have infrared. One of the features of the electromagnetic family, electromagnetic spectrum, that as you move from infrared, visible light, ultraviolet in this direction, what happens to the wavelength? The wavelength decreased and the frequency increased, but the speed is constant, which is the speed of light in air. I told you about it right now, the speed of light in vacuum or air. Okay, so infrared, visible light, ultraviolet. So violet, it has smaller wavelength than red. So state how the wavelength of violet in air differs from red. It is smaller.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.